Hello friends, welcome to my YouTube channel. Today we will learn physics. We will talk about gravitational waves. I hope you enjoy it. When something moves, it creates waves. For example, if you wave a stick in the water, you get water ripples. Make a piece of metal vibrate very quickly and you will get pressure waves in the air. Shake a few electrons super fast and you will get radio waves. What if shake a planet or a star very fast and you will get gravitational waves? Gravitational waves occur because the effects of gravity do not travel at infinite speed. So if the sun suddenly moved a few 100,000 kilometers to one side, the changed gravitational field would take some time to propagate. And if the sun wavered from here to there and from here to there, instead of a single pulse, we would get continuous gravitational waves. But what is waving? In the case of water, the liquid level rises and falls as the waves pass. In the case of sound, the air pressure creates and decreases as the waves pass. In the case of radio or telephone waves or any other electromagnetic wave, the electric and magnetic fields become stronger and weaker as the waves pass. And in the case of gravitational waves, it is the gravitational field, the one that gets stronger and weaker as the waves pass. You can tell if a wave has passed by looking at how the particles that hold a cork in the water behave up and down. The electrons in a radio antenna move for one side and for another because of the changing electric field. And the people or planets or cats that we have floating will move to one side and to the other because of the changing gravitational field. Although in this case the peculiarities of gravity make the things floated before they pass the gravitational wave, they will not feel that they are moving. But if you measure the distance between them by sending a pulse of laser light and measuring the time it takes to return, you will see that the distance between them increases and decreases. In practice, physicists don't measure gravitational waves with floating jacks. They use very expensive and sophisticated mirrors that are basically floating because they are hanging from pendulums suspended on isolation tables suspended on more isolation tables. Or even really floating because they are on satellites floating in space, although this has not yet been done. The reason physicists need these sophisticated floating mirrors to detect gravitational waves is because they are very weak. For example, the electrons that vibrate in a radio antenna to make electromagnetic waves also make gravitational waves. They are matter moving back and forth, after all, but the waves they make are super weak. A 200-watt radio transmitter emits gravitational radiation with a power 1 billion trillion times smaller. And that's why we can only detect the largest astronomical events and cataclysms like neutron stars spinning very fast or emerging black holes or the Big Bang. So far, we have only detected black hole collisions, but that alone is enough to deserve rain or wise very bearish. Kip Thorne and the 1600 scientists from around the world who have honored the Nobel Prize in Physics in good time made this possible. Do not forget to follow us on our social networks on Facebook and YouTube.